periodic trends and properties that are some physical are there, chemical are there, that we will be learning, and we will be seeing the summary of full chapter. So let's start, and do watch, do share with your friends of ICSE 10. Now let's start. Density, MP, that is the melting point, and boiling point. These are the physical properties of periodic table. You can see periodic trends. Now, across a period, if we are going across a period, we will see density and MP means melting point of elements increase gradually and slight decrease thereafter. मतलब बहुत gradually वो increase हो जाता है और धीरे धीरे slightly decrease होता जाता है. Can you see a gradual increase and slight decrease? Like this, it is the density and melting point of elements across a period. Across a period means like this, okay? Means left to right. So here you can see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So you can see here density is 0.5, 1.8, 2.3, 2.2. Till here it is increasing. After that it has no density. So it has decreased totally. Now here melting point in Celsius. There also you can see gradually increasing and then slightly decreasing. See here 181. Here it is gradually increased to 1277, 2030, 3727. So it has gradually increased and then it is slightly decreased. You can see minus 210, minus 219, minus 220. This is all decreasing. Okay, you can take the example of here also, like here it is increasing 98, 650, 660, 1410. It has decreased now 44, 119 and minus 101. So it is gradually increasing and slightly decreasing across a period. What? Density and melting point of elements. And down a group, okay? Density increases gradually and melting point and boiling point of elements decreases gradually. So density is increasing down a group and melting point, boiling point is decreasing down a group. You can see your density is increasing 0.54, 0.97, 0.86. Yeah, but it has increased, right? And here melting point 181, 98, 63. It has decreased. Okay, here it has increased and here it has decreased. So melting point is decreasing, boiling point is decreasing, D, and here it is increasing, I. Here also 1347, 880 and 760. Down a group it is decreasing. So melting point, boiling point decreases and density increases down a group. This is very important. Now chemical properties, periodicity and properties of compounds of elements. Now varies from across a period and this is down a group. Now oxides. Across a period, they are strongly basic to strongly acidic. So across a period when they are going, oxides are going from basic to acidic. Hydroxides are going from basic to amphoteric. And oxyacids are going from weak oxyacids to strong oxyacids. And hydrides are going from strongly basic to strongly acidic. This is important across a period. Oxides, hydroxide and oxyacids and hydrides, how they go across a period. And down a group, oxides go acidic to basic, hydroxides go less basic to strongly basic, oxyacids go strong oxyacids to weak oxyacids, and hydrides go less acidic to more acidic. So across a period and down a group, how oxides, hydroxides, oxyacids and hydrides go, this is important. Now reference, arrangement of stable and unstable elements in the periodic table. You can see elements sodium, potassium, uranium. Okay, this is only about stable and unstable elements in the periodic table. That is for reference, you can refer that. Light metals, elements arranged in the periodic table having a neutron upon proton ratio around 1 are stable elements. That are light elements like sodium, potassium, like that, they are light elements. Heavy metals are uranium, okay, and they are considered as radioactive unstable elements. Which elements? Elements with N upon P, that is neutron upon proton ratio about 1.5. If the ratio is about above 1.5, then they are called as radioactive unstable elements. Like example, uranium, that is a heavy metal and radioactive. So it has ratio above 1.5. Now trends across a period, this is also a reference. Now what we are going to see, that is the summary that we have learned in previous parts of this on this channel. You must have learned, and if you haven't watched that, do watch that part. You can see atomic size, that is decreasing, ionization potential increasing, electron affinity increasing. But how? Across a period from left to right. Atomic size decreases, ionization potential left to right increases, electron affinity increases, electronegativity increases, and metallic character decreases. Here you can use any mnemonic or anything to learn this, that atomic size and metallic character both are decreasing across a period and other are increasing. That is ionization potential, electron affinity, and electronegativity. These all are increasing across a period, that is left to right, like this. Now trends in periodic properties down a group. Down a group, atomic size increases, ionization potential decreases, electron affinity decreases, electronegativity decreases, metallic character increases, valence electrons remain same, and number of shell increases by 1. Of course, down a group, number of shell are increasing. Here also you can make any mnemonic, and remember, down a group, what happens, this already we have learned in previous parts. This is only the summary that is given on page number 15. You can refer to that. Same it is, you all have to learn. If you learn this summary chart, then full chapter you have done, you can say like that. But then also you have to read factors and all that. But yeah, this summary table is important. Reasons for trends in periodic properties down a group. There are some reasons, and for above reason, nuclear charge effect is now dominated by increase in number of shell or increase in atomic radar. Here all it is just the summary what we have learned in previous parts. So here you can see group 18 elements. Now we have to read this. Group 18 elements, atomic radii more than group 17. Outer shell is completely filled, resulting in force of repulsion, increasing atomic size. And electron affinity is 0. Means elements with stable electronic configuration find it difficult to accept electrons from others. Metals compared to non-metals, metals lose electrons. They have large atomic radii and have less ionization potential, electron affinity, and electronegativity. These are the symbols you have to learn that compared to non-metals. So they have electronegativity, electron ionization potential, electroaffinity. These are less in metals and they lose electrons and they have large atomic radii compared to non-metals.